Apology. I forgot I stopped it when initially started. So, um, like I was saying, apart from the fact that you have to specify what would be your VM type based on the purpose of the VM this use. Each of the VM have you already have templated config or specs. Let me use that word, templated specification. So which means you have for a general purpose VM now, you have them in different specifications. You have two CPU plus, let's say, 4 gig RAM. You could have 3 vCPU with, let's say, 6 gig RAM. These are not standard. I'm just using these as instances. So you have them in that particular regard. So which means it doesn't offer you that extent of flexibility where you have to specify your own. Let's assume I want 1 gig RAM and 1 vCPU. So you have to select from that standard template. But those standard templates have been so designed such that yeah, they are range of specifications or configurations that you would normally put together. So in addition to these specifications also, you'd also have standard OS disk size attached to them. So which means that when I pick up a particular OS template to use, it has a standard CPU specify, a standard RAM size specify, and also a standard OS disk size. So that OS disk size is standard and is default. It might not be enough for you, but however, it makes sense because it follows the standard approach of you setting up a server for use, which is you don't place your OS and your data on the same disk. So what they have provided for you is a disk space that will be enough for the operating system to load and function. When you need more disk space to put your data in it, you have to add additional disks, which is optional. Then you also have a temporary disk, which is also another default disk that is specified. It is called temporary because it is not meant to house data. The idea behind this temporary disk is that if I have my host this way, let's assume this is my host computer system on which I have my hypervisors, whatever hypervisor it is, then I have a VM this way. Now, primarily, most times the storage, which is the disk storage we use within the cloud system, is actually coming from system. You remember when we were talking about storage system, and we talked about the different types of storage. We talked about the directly attached storage. We talked about the storage area network, and we talked about the network attached storage. Under the storage area network, we talked about two major protocol, probably approach to connecting to a storage system that is a network. We talked about iSCSI, and we said we have fiber channel. So this managed disk falls within the system of storage area network, which means your VM will be connecting to that using either iSCSI or fiber channel, but a large number of times it is iSCSI because the storage system itself is on the network. So your VM just connects to it across the network. Then becomes the OS disk. But it is not a directly attached disk. So which means there are certain advantages, and the primary advantage that a directly attached storage would have over a storage attached storage is that there is no latency, read-write latency, because a directly attached storage is directly connected to a physical computer system, and there is no intermediary between that write operation. Meanwhile, for a storage attached network disk, it has to go across the network, which means it can be impacted by the speed of the network itself, even though it's very fast within the cloud environment, such that it is insignificant. However, there might be need for you to use directly attached storage. So what Microsoft has always done is to present a temporary disk, which is a directly attached storage on the host computer system itself, now exposed to the VM. So which means this temporary disk is a physical disk on the host server on which this VM is running, and that physical disk is exposed to the VM. So the reason why it is now called a temporary disk is that if for any reason you restart your computer system, your server, the content of that particular disk would go, because the disk is not owned by the VM. So when you start the VM loses that disk, but another fresh one is presented to the VM when it comes up. That's number one. Then number two, if for any reason maybe this physical computer system is faulty, and as part of the redundancy and resiliency design within the cloud environment, this VM needs to be moved to another host. It can't go with this physical disk. So it would also lose the physical disk. Whatever you have written in it will be lost. So that's why it is called a temporary disk. And you're always advised not to place any data or information, any physical data or information within that disk. Now, what could be the possible use of this disk? You could use it for swap purposes or paging. Swapping or probably paging is actually a methodology where you're able to boost performance of RAM by making use of space on disk. You know, your RAM is a bench area where work in process stacks are actually processed. A large number of times, that space may not be enough to handle work in process stacks, but there are methodology that allows your RAM to borrow disk space on your storage for that what's it called, lag. So it's always called paging or probably swap file, and it's always used within all operating system purpose. The reason why it can serve that purpose is because naturally the contents of your RAM is temporary. Anything in your RAM when your system goes up is lost, so which means it has to be recreated. So even if such content are also placed in this temporary disk, then it makes sense. Then you now have additional disks that you can attach to your VM. This is where you can now define the disks that will be used for data purposes. This disk is also presented using a SAN technology. Is that iSCSI or parafin fiber channel? But most likely, what's it called? iSCSI. So even when your VM moves around or probably the VM restarts, the disk is still persistent. It is available, and you can use it. So your OS disks and your data disks are based on the Azure storage service. Probably they are VHDs. They are called virtual hard disk drive. The same VHD that if you are familiar with Hyper-V, the same VHD that you use within Hyper-V is also what we are talking about here. However, those VHD are also stored on a storage type called a page blob, which we'll talk about much later. And you could have them in 3 tiers, depending on speed, how fast, IOPS, input-output operations, how fast you want it to be. You can select a disk that is standard, which is based on your normal hard disk drive or probably ordinary low premium SSD drive, or premium SSD, which is going to be faster, or ultra SSD, which is going to be faster. Your choice of disks would also depend on the requirements of what you want to use the virtual machine for and criticality of virtual machine. Especially when you are doing high database operations, where you want your database to be very responsive in indexing, in querying, responding to what's it called, request. You want to go for premium or probably ultra SSD, where your read-write speed and response is not that important within your requirement. Maybe you are just using that storage as a dump site for storing data and not really performing operation off it. It can always be a standard disk. And when creating disks for virtual machines, They can be managed, they can be unmanaged. In the past, at the initial start of Azure, what you have are unmanaged disks. Unmanaged disks meaning that you have to create, wherever we still talk about storage account, create your disks off your storage account, then you now attach it to your VM. But now you could always directly, don't need to create a storage account. You could just request for a disk and have it assigned to a particular VM directly from that particular VM. That's why it is called managed, and it's always the recommended approach because it has more benefits. The resiliency, availability, and SLA is higher to guarantee that your disks would always be preserved than if you do unmanaged. Where unmanaged, you have to decide how highly available you want disks to be on your own. And when you create virtual machines, we've seen how you connect to your virtual machine. Let me bring up my portal. How you connect to your virtual machine depends on what type of virtual machine you're creating. Can you see my browser on my screen now?
Yes.
Yes.
Okay. So we are familiar with RDP for Windows. However, use RDP because primarily Windows is a GUI-based operating system. However, you could as well connect to Windows using the command line, using the Windows Remote Management service, which is a service that runs within Windows that allows you to do non-interactive connectivity and management of the Windows operating system via the command line, primarily PowerShell or any other tool that works with the Windows Remote Management service. So due to the fact that we've always created the Windows virtual machine, and I believe anybody without thinking now at this point can just go to Azure and spin up a Windows virtual machine. I'll go ahead and spin up a Linux virtual machine. I have one running here, so I'll go ahead and just bring up. So like we said, I have let me call this five resource group. We have to create a resource group. So let me call this Linux server 01. We still remember our choice of region would always be based on where we think is closer to us primarily. Then maybe another factor would also be cost. So apart from, so let me come and explain this part here where you have images. So you would see that when you spin up a VM within Azure, you don't go ahead to begin to install the OS just like you would normally do within a physical environment. And that is because OS has been pre-imaged such that when you specify what OS you use, that image is just loaded. An image is a pre-installed OS that the state has been captured for faster loading within your computer system and use. So that process of you having to install afresh and do all those stuff has been taken care of because naturally there will be no way for you to do that since you don't have access to the hypervisor management console that is used within the cloud to begin to perform that operation. So that bit has also been done for you. So you just select what image you want to use and it loads. Then you now have different types of image. You'd have Microsoft own predefined image for different standard operating system. You have their images for Windows 10, images for server, image for Linux, and different flavors of Linux. You would also have vendor-specific image as well, where certain vendors have actually customized certain OS image for specific use cases, so that let's take for instance, maybe I need to okay, I need to install okay, let's say Vim. There's this application Vim that is used for backup. I need to install Vim, or I need to set up Vim to backup, maybe in the cloud or probably on premise. But one of the target infrastructure you can use for Vim is cloud-based VM. So what Vim has done is to, if your platform is going to be Linux, they have pre-customized a Linux image that has the Vim application pre-installed and pre-configured. So if the purpose of that VM is to use it as a backup server for Vim, then you could as well just go ahead and make use of that particular image instead of you using a standard Linux image that you now have to download and install Vim and do the configuration. So you have it that way. Then you also have marketplace images, where there are images individuals have customized for certain purposes, but they feel like every other people can also benefit for it. Then they make it available in the Azure marketplace, either for free or probably for a particular token. So whatever it is, the level of customization that they have offered, that they've done on it, then you don't need to do it all over again. So they've done it for you. You just pick it and you go. So here you could see the different images and from who the vendors or probably publishers are. Like these are all Microsoft images for Windows 11, Windows 10, they are standard. This is canonical for Ubuntu. You have Windows 7. Even though Windows 7 is no longer supported, Microsoft is offering an extended support within the cloud environment if there's a need. And one of such use cases is if you have a legacy application that still needs to work within Windows 7, then they make it available within their cloud. They're managing the extended support. You also have for Red Hat, and so these are from standard vendors or probably standard publishers. And if I come here, let's say I come under, say, security, which is also a very common use, where you have security vendors. For instance, if you want to have your FortiGate firewall, even though on-premise, FortiGate firewall is an appliance. All I need to understand is that a large number of these network appliances runs OS just like a normal computer system. But those appliances has been pretty engineered to serve the purpose for which they are what's it called, that they want them to do. But in a case where it is in the cloud, they have no option other than to go back to the traditional method where you have that still engineered OS installed on a virtual machine and still used for that particular purpose. So if I need a FortiGate firewall within the cloud, what I would actually have spin up is a firewall that is configured on a VM. So in this particular case, they have taken whatever OS image they want. They have preset it up with whatever it needs to take, all their OS configuration and stuff like that. Then I just need to do this, select this and spin it up. But you can see this free trial because even the use of FortiGate itself is what you need to pay for. So you could select from, and this was the VM I was talking about, and you'd have them several or this someone setting up an Active Directory domain controller, Active Directory for edition services pre-configured for you to just select and use. So that's the idea behind the images. So I'll go back here. So my standard image that I choose to use now is let's say my Ubuntu server 204, and so you can see these are sizes standard I was referring to, that you have the sizing has been standardized such that, so it's not like you'd have to specify what will be your own, you key in what will be your own memory size, what will be your CPU size and stuff like that. No, you don't do that. They've been standardized in templates and you can see them in different categories. you have the D series, which is recommended for general purposes. D series version 4 also for general purpose. The B series, which was for full CPU performance. E series. So you have them in each of those series in these what's it called, letters. So depending on what you want to use them for, that is what you go ahead and select. But mind you, not each categories or probably each specifications of VMs are available in all regions. You could have some that are available in a particular region while the others are not in that region. And when we come back here, you can see the number of vCPUs is always fixed, number of RAM. So which means if you need to increase the resource on your virtual machine that you had spinned up, what you need to do is just change your sizing. You now have to select what would be another standard size for application. And this is referring to what is the size of the temporary storage that is available on each of those machines. And these are standard data disks that you could have, but naturally you could do more than that. So here I would, to save costs, I'll do for this, which costs $41. I'll select that. And for Linux, like we said, the primary way you'd connect to Linux is either use a password, even though it's still going to be through the shell. Either use a public key or probably a password, but it's always advisable you use a public key because it is more secure than you using a username and password. And it automatically generates that public key for you, which you now have to select or probably download rather when you create this. So I'll go ahead for this. If I come here, I can choose to create and attach a new disk. If I don't do this, the standard OS disk will be there and the temporary disks. But I can, even if I don't add additional disks here, I can go ahead and do that even after that machine is up. And when it comes to my disk type, I can specify from any of these types, either premium, best for production and performance sensitive workloads, standard SSD for web servers, or probably HDs for backups. And you can see for backup, naturally, within a backup, you are not doing much of a read write. You are just writing data to the disk for keep. You are not interacting with that particular data. So there's no point spending so much money on a premium SSD or probably even a standard SSD. You just go for a standard HDD. So I'll go ahead. We'll still talk about networking much later. Then I'll go ahead to say, so this is my FMR, which is your temporary disk that comes with the device. Then here you are doing managed disks. Like I said, you have your disk can either, your OS disk can either be managed or managed, but it's always recommended that you use managed disks because the availability of that particular disk is being managed by Microsoft, and much more later, the availability or the use of unmanaged disks would actually not be supported. So I'll go ahead and create this guy. Something failed, and what's that? And then networking. Okay. Still come back to networks. And come back, start from here first. Resource group. I thought I created one resource group now. Okay, let me create it again. I'll call this week 4. So all this stuff went up. Linux server, this is in server 01. Yep, yeah, this remains. Yeah, great. Go ahead and say create. So this fact that I've chosen the option of using a SSH key to connect to this device, it's asking me to download my private key, which I'll do here, and it's going to save that private key for me. Still come back to using that private key to connect.
Hello, sir.
Yes, I can hear you.
I just want to ask a question.
Yeah, go ahead. Go ahead.
So when I deployed at any point you forget your password, how do you do a reset on that password?
At any point you forget your password to your VM.
Yes.
So there's an option. If it is an admin password, there's an option within the console of your VM that helps you with
Okay.
some form of password recovery.
Oh,
We'll
okay.
check that.
Because I had that issue the last time.
Yeah.
Okay, sir. Thank you.
Yeah. So for connecting to a Linux machine, naturally you would have to make use of. Can you see my console? I have PowerShell up now.
Yes.
Okay. So you'd have to make use of an SSH client. You could make use of the SSH client on your Windows 10 upward device, or one of the most popular SSH clients as well use is PuTTY. Some of us are familiar with PuTTY, but in this case, I would use this. So now this guy is done. If I go to the resource, by default, there's a user account tied to the SSH key that was created. And if I come to connection, connect, here, the user account is this guy as well. So for me to connect to this guy using SSH, especially from the command line, I'll need this. And if I'm using PuTTY, at the minimum, I'll need this username and I'll just need this IP address. This is the public IP address assigned to this machine. So I'll copy this guy. I'll come here where my private key, I have my private key downloaded, and I come to download, have it here, copy part where this guy is. Change this to that key. Right down. Yes, right. Now I have access to my Linux machine, from where I can begin to do other things that I need to do. So this is a Linux. So that's how you connect to a Linux machine. And going back to the slide, we've seen this. Apart from you having Azure to create a key for you, and now this key we are talking about, if you remember, we are talking about public infrastructure. We talk about public key, private key. So one of the applications of those public key, private key is also in the use of what's it called, SSH. You could as well pre-create your own key and specify that key for Azure to use in the creation of that VM. But in that particular case, you have to create the VM using either PowerShell or probably Azure CLI, where you're able to specify that key. Now, one of the selling points for the cloud is actually resiliency. It offers you resiliency, some element of redundancy and availability by design, even though you need to be intentional about your setup, about how you set up your infrastructures to be able to take advantage of those resiliency, redundancy, and the likes. However, there are a number of factors that may make your service to go down, and they've been categorized into these three factors. You could have unplanned hardware maintenance in a situation where the particular host computer system is flagging an alert that there's a component that is about to go bad. Maybe a disk, maybe a network, maybe it's actually been showing some kind of symptoms that shows that something might be wrong and this server might fail at any point in time. So when that happens, it is flagged as an unplanned hardware maintenance. And what action is performed on your VM? Your VM is moved. Your VM is moved from that host to another host. For a number of us that may have worked extensively with Hyper-V or probably VMware, we understand the concept of live migration, vMotion, and the rest of the like. That is moving a virtual machine from one physical host computer system to another physical host computer system without any significant interruption in the operation of that particular virtual machine. Then you could also have unexpected downtime. This is when a virtual machine fails unexpectedly. You would have an automatic healing process, which most times requires that particular virtual machine to restart. So you may not do anything on your own, but you'd just notice that the virtual machine may restart. Then also, you also have planned maintenance. For planned maintenance, this is always be the case if there's a need to apply update or upgrade. A large number of time, it has no impact on your virtual machine. Your virtual machine does not restart, it does not reboot, it doesn't do anything because the update here is on the host. Now, mind you, when talking about shared responsibility, the shared responsibility model that we talked about in the earlier part of the lesson, your cloud provider is not responsible for patching your VM OS, especially when you are doing infrastructure as a service. So if I put up a virtual machine now, even though it's a Windows virtual machine, Microsoft, being the owner of Azure, would not patch it for you because that is not part of their responsibility. Their responsibility is patching the physical server on which your VM runs, which is their own responsibility. But the VM as a service or as a product or resource that you have paid for and you have bought, you have that control to ensure. So when it even comes to security, there's a shared responsibility, what's it called, in terms of cloud security. There are certain bits of security that your provider is responsible for, and there are certain bits of security that you are responsible for. So they wouldn't patch your OS for you, but they can provide you with tools for you to be able to manage the patching of your virtual machines. So in this case, you're not expected to do anything. Now, it's also as part of redesigning or making use of resources to take advantage of the resiliency and redundancy features available within the cloud, especially within the Azure environment in this case. We need to understand the update and fault domains. Update and fault domains. First, the concept of point of failure when designing redundancy is that you want to be able to identify what is that thing that can fail within a setup, within an architecture, and would cause that architecture or that particular service to go down. So, for instance, if I set up a network, my switch can be a point of failure, my cable can be a point of failure, my CPU can be a point of failure, and the rest of them like that. So when you identify each of those points of failures, then you now begin to design redundancy around each of them one after the other. Can I have two switch that is configured as a cluster? If one goes down, the other one works. If I have two switch, can I have two cables? If I have two cables, can I have two NIC adapter from one machine connecting to the same network? Can I have two CPU? Can I have two RAM? You know, stuff like that. Just begin to design that. So when it comes to faults within this environment also, Microsoft is saying, or probably the standard that you identify, so within their own system, they have identified what could be points of failures that could impact your infrastructure. And they have designed technology around it that if it fits into that particular technology, then you can always manage that point of failure. So first, one thing that could make your device go down from this slide that we talked about earlier is a patch update. If the host computer system is being patched, it can impact your own VM. Another thing is if there's a fault within their own infrastructure, maybe the rack on which the server hosting your VM is on, if the power there goes down, if the cooling there goes down, if there's what's it called? Maybe if the storage there goes down, if the network goes down, it can always impact your own VM. So they are now saying we have created fault domains. What are these domains? These domains are individual units that if any of the underlying factors we have identified, either update or private component failure, if it happens, whatever is running on that particular unit would be affected, will be impacted. So for instance, update domain. Update domain is just a unit that can be patched at a time. So it could be a whole rack, it could be a blade. Within design of physical infrastructure, you would have a rack. A rack can be very tall, and on each of those racks, you would have blade servers on which you can now begin to have your VM. So if the whole rack is being patched at a time, then that's an update domain. If it is the blades that are being patched at a time, then that's also an update domain. Then you also have fault domain. Fault domain would also be a unit of infrastructure that shares underlying components together, be it power, be it cooling, be it network, such that if the power goes down, all the old service running on it goes down as well. If cooling stops, it will overheat and it affects all of them. So how do you make use of this? There are several of these fault domain and update domain that have now been created. So which means by design, number one, you have to put into consideration redundancy. So which means if I'm setting up a VM for a particular service, if that particular service is critical, it shouldn't be just one VM. I should set them up in sets, a minimum of 2. But even if I'm setting them up in sets, a minimum of 2, I should be intentional on how I place them. Because if you place the 2 VM on the same update domain, it means that if that particular unit is being patched and both of your VMs are on it, it will still be impacted. If I place the 2 VMs on the same fault domain also, so which means if there's a power failure, there's a network failure, there's a cooling failure, and is affecting that unit, both of my VMs would also be impacted. So what do you now do? You intentionally spread your redundant components across different fault domains, across different update domains. So if I have a web server that is meant to be highly available, the primary point of designing redundancy or resiliency is that it shouldn't be just one. I should make it 2 servers performing the same function. That's the first thing. Then if I'm doing that also, I should be intentional, placing them in different fault domains and probably in the same, in different update domains, so that they are not impacted by patch and they are not impacted by component failure. Now, when we're talking about patch or private component failure, we are still talking about just within the same data center. We talked about zones, we talked about regions. You have availability zones. Where availability zone can be one or more data center just within a particular region. So for a particular zone, you could have more than one availability zone. For a particular region, you could have more than one availability zone. And for a particular availability zone, you could have more than one data center. They could be 2, they could be 3. But each fault domain and the update domain would most likely be speaking to a particular zone. If you now want your system to be zone redundant, so which means that you could also now begin to talk about other features like you looking at availability zones. I hope this part is clear. Hello?
Yes, it is.
Okay. So Now, I said your primary design would always be that you'd make your service be available, try your virtual machine in this case, to be available in pairs. So you'd have what referred to as an availability set, where an availability set is you having two copies of your servers or probably of your VM, most times that are performing the same functions, and you intentionally place them in different fault domains and in different update domains. So you configure them into different availability sets. So what our availability set means that if I have two VMs, they won't be placed in the same update and the same fault domain. That's what the availability set is talking about. If I have two VMs, which is the minimum you could have more than that. If I have two VMs and you say you want them to be, you set them up for availability sets, they won't be placed in the same fault domain and the same update domain. And that gives you 99.95% SLA, service level agreement. So which means 99.95% of the time, your VM, at least one of the VM would be available, because both of them can't go down at the same time due to a component fault in the data center or an update being applied. And if you use managed disks, you can say for managed disks in this particular case, you don't go ahead to manage the availability again, like I said earlier, because that is being managed for you. And that's why it's always good to use, when it comes to using disks, you always use managed disks for virtual machines, because the whole availability and resiliency of that is being managed. It's not your headache again. What should be your headache is the resiliency of the virtual machine themselves. And you could also now increase the availability of both virtual machines. Now you could, when you have the virtual machines in our availability set, you could use them in silos, or you could use them to present one service if they all are behind a load balancer. If you remember, when we spoke about high availability, we mentioned the load balancer. And what the load balancer does is to present service running on each of these virtual machines as one, such that if request comes in at the back end, they are distributed across each of the virtual machines. So it doesn't really matter which virtual machine serves your request. So if eventually one of them goes down, user wouldn't know, because the service will still continue to be served by the guy standing.
Hello. Yeah, so, hello, Raj. Please,
yeah,
before you move on, I have a question.
Okay. Yeah.
If you can please go to the previous slide. I was just wondering that what happens if I put my VMs in the same fault and update domains? Like, is it not intuitive that the system, that's Azure, should prevent me from doing that? So okay. What is the ideal case, or rather, what would be the ideal instances of that will cause someone to put them in the same fault and update domains?
So number one is we need to understand that when consuming cloud services, you have to be intentional with your design. And that is why when it comes to the use of cloud, architecturing is a very key factor and is a key responsibility on its own, because you just don't go and use. You have to understand. So number one, even outside the cloud, if I let's assume on your PC, on your laptop now, which can be a server, if you have let's assume you have VMware or probably VirtualBox or Hyper-V on it, and you set up a virtual machine on it, and that virtual machine is being used critically. When your system is updating, what happens to the virtual machine?
It comes down. It comes down naturally.
Exactly. So it goes down, and when the system comes up, it comes up. When your system is faulty, maybe it has a bad disk or probably bad memory or probably bad screen, you also can't use that virtual machine because the host. So which means a key point of failure to that virtual machine is the host on which it is running itself. Even if nothing is wrong with the virtual machine, if something goes wrong with the host computer system, that virtual machine itself is not usable. because I have just one of it and running on just one computer system. So let's now assume that I have two laptops and I have created duplicate copies of that virtual machine on two different laptops. If one laptop is faulty, I can go to the other one and continue to use the same VM. In this case of laptop, because there's no direct connectivity between those laptops, I might be a little bit impacted because maybe some data, my latest data may not be on the second laptop, and I have to now power the second laptop I'm going to use. But just for the case of scenario, probably, what's it called? Just giving an instance, I have it available on that second laptop, and I can just switch to that second laptop and begin to use. So Microsoft has made those options available. But when it comes to the use of cloud services, apart from architecturing, number two thing that is a factor is also choice. They have made choices available for you so that you are always able to make the best choice that meets your requirements. If there's no need, for instance, your services can be classified in criticality. By default, they are telling you that under standard temperature and pressure, or under standard environment and the technological factor, if you set up one VM within our environment, we guarantee you 99% availability. You see that extra 1%, it's a standard within the what's it called, IT ecosystem. There are factors, a large number of factors that you can't control. But they are now coming back to say, you see that 1%, we can give you back a little bit of it. We would go extra mile to begin to identify points of failures for that 1% and begin to design solutions around it so that you can begin to reclaim that 1% again. But now it is if you want it. If you want it, we've made it available for you. You use it. But if you are okay with that 99.9% standard, then it's also fine. Because there are cases where I could need a VM. It is running a service that is not too critical. It is not even within my top 100 critical service. Then why should I be paying a lot of money to make it highly available? It makes no what's it called, sense. So those are scenarios where you can choose to use a particular service without considering the availability factor, because you don't consider it as critical. At any point in time, you could go ahead and use it. If it's not available for 10 days, it's no issue. And it's not possible that the Azure service will go off for 10 days, because if you look at maybe if we do the math, if you do 365 and do 99% of 365, I'm not sure if it is up to 10 days. So which means it's not possible for the Azure service to be down for 10 days. But if I'm saying that I'm fine, if it is down for 10 days, it's down for 11 days, it's down for 12 days, then why should I go and pay for components that will make it, or why should I have duplicate copies of it? So that's the idea. So it's choice and what's it called, design. So now looking at this, you'd have, if I have a single VM that is on a premium storage and a managed storage, when you have issues like OSDs issues and stuff like that, this guy is protected. So I would have the SLA they are committing to you. If you do this, if you use it, if you have a single VM that is running on premium storage, we are committing 99.9%. And the point of failure that we have identified here is primarily maybe the disks. And we are saying if you use premium, you are covered, standard. If you need more, you want to be covered when there's an issue with the rack, maybe component failure, power failure, your PSU, power supply unit is faulty, the network cable is faulty, the core switch servicing that particular rack also went bad, which are issues they don't have control over naturally. So they are saying if you set up your VM as an availability set, we can give you an extra 0.005% assurance, making it 99.95% that your service will be available if you set them up as an availability set. So which means you have more than one VM, and in using that availability set, you'd make them available in different fault domains and different update domains. Then we'll guarantee you 99.95%. Okay, you want more. Now, we talked about availability zones, and within availability zones, if this is an availability zone, you can have different data center. Let's assume this is one data center, this is one data center, this is another data center. Then this is another availability zone. And the two availability zones are within the same region. It's possible that something goes wrong. All the 3 or 4 data centers within this availability zone goes bad. And I gave the instance of a rack center, main data, and MTN. Within the concept of Nigeria or Lagos, as it may be, which is in Nigeria, let's assume Nigeria is a region, then you have what's it called, Lagos. These 3, Lagos alone can be referred to as a region. And you have rack center referred to as one availability zone within this region, main data as availability zone 2, and MTN availability zone 3, where each of them have got data center. Now, when you go to each of these data center locations, their actual data centers, at least for the 2 that I know of, main data and rack center, most times are in these container capsules. So you have one data center with its own control of power, cooling, fire management, another one. And each of these guys are now separate data centers on their own. So they are saying that if you are making use of an availability zone, you set up your VM such that one would be in rack center and another one would be in main data. You don't put both of them in rack center because something can happen. The rack center zone goes down. Let's assume there's flood. The whole of Lekki axis was consumed, and Ogombo also got impacted. Then the main data center as a whole there now, something went wrong. That's one zone down. But if you have intentionally set up more than one VM and put one in zone 1, put another one in rack center. Rack center is on the mainland. This guy is on the island. I don't know if there's any flood that can flow from the ocean on the island and consume the data center on the mainland. I don't know, but most likely not possible in this context. So which means the VM I've placed in rack center will be available. If you do this, you are covered with power network issues and related factors. So if one zone goes down, you have the other zone. In this case, we offer you 99.99% availability. Then if you now want more again, you now begin to talk about interzone or probably inter-region resiliency, where I have my VMs replicating from one region to the other. So if something goes wrong with a particular region, like a natural disaster, mind you, I said the Lagos could be a region. So whatever natural disaster that can consume the whole of Lagos, such that all the 3 zones in Lagos are down. Then if you have done replication to another region, your virtual machine will be available there. But this is also a factor of your recovery point objective and recovery time objective, which is meant to be a standard baseline for each organization. And it will be a justification for their spend. Do we need this? If we need it, then we'll be able to spend for whatever cost it comes with. If we don't need it, then there's no point. That's the idea. So availability zones, we had said you have independent power cooling networking and protects you from data center failures, and you get 99.9% SLA. And at what point do you specify, before we come to scaling, at what point do you specify this? We looked at that. Let me come back here. So I'll come back to home again. I'll go ahead to create another virtual machine. Yes, I can hear
Hello,
you.
Raj. Sorry, I just have to chip in, if you don't
Yeah,
mind.
sure. Go ahead.
So we've seen where a company will have their data center in Lagos and have um, they'll have their they'll have their main data center in Lagos and still have their backup data center in Lagos as well, but
Yeah,
just in two different locations.
yeah.
What kind of thinking goes into such a design?
Yeah. So a lot would go, and that would also be part of business objective and strategy. So if we say Lagos, number one, you want to look at what is the chance. So if I have two, so let's say main data and Lekki as the two locations. One, maybe their primary data in rack center and their secondary data in, let's say, main data. So number one, you want to look at what is the chances that anything consumes Lagos as a whole, such that both of them will be down. Very unlikely. Has it happened in the last 10 years? Say no. Last 20 years? Say no. Okay, we can live with that. Even if it happens, say maybe once in 10 years, we can live with that. For instance, looking at that, what do you call it? This Lekki Sorosoke issue that
So,
happened, was it last year? If that
yeah,
consumes the whole of Lagos, you could have instances where people begin to attack some of those facilities, and some of those facilities can be impacted. Yeah, it's possible, even with the whole lot of security available. But has it happened before? No. Last 10 years, last 20 years, what's the chances it will happen? Maybe 0.05%. Oh, we can live with that. So let's have both of them in Lagos. So the question will now be, okay, where in Lagos? Both of them on the mainland, both of them on the island. Oh, mainland, something can happen. Oh, mainland will not be accessible. Something can happen. Oh, the whole of the island will not be accessible. Okay, let's split it. One in mainland, one in, what's it called? Island. But that's Lagos. Let's look at let's say some regions in the US in the last 3, 4, 5 years. How many tsunami issues have they had? They've had up to 5 or 6. What is the chance that they will have another one in the next another year? It's very high, say 60%. Oh, we can't place our infrastructure there at all. That's one factor. Or okay, because we have very large presence there, we can place a temporary infrastructure there, but still have a backup infrastructure outside that region entirely. It's also what's it called possible. So those are some of the thinking that goes into designing business continuity or probably redundancy plan, or probably even infrastructure, because it's a plan that now speaks to how you implement it in terms of your actual infrastructure. Those factors of what could impact your service and how can you begin to use your technology to mitigate that is what will be the thinking process. I hope that answers the question.
thank you.
So if I come here to say I want another virtual machine, now at this point I have availability options, and it says Azure offers a range of options for managing availability and resiliency for your applications. Architect your solution to use replicated VM in availability zones or availability set to protect your applications from data center outages and maintenance. So you have options. I can say no, infrastructure redundancy is not required. I don't need it. Or I can say I want to use these two, availability zone, where you have physically separate resources in an Azure region that is using a main data and a rack center, which are zones within the Lagos region as an instance. Or I have an availability set where availability set limits me to just one zone, but we are saying that within that zone, oh, two infrastructures wouldn't be on the same rack, or probably physical infrastructure. They won't be on the same rack, or they won't be on the same fault domain, or they won't be on the same update domain. So you have to specify that here. So, but if I go ahead and do this and create this, then I specify what zone do I want. It means that after creating this, I have to go back and create another one and place it in a different zone. Or if I come back here to say what I want is an availability set, then I have to come here to create my availability set where I have to specify, okay, let's say this one is a AV set 001. Then I have to say, okay, if I'm making use of just 2 virtual machines, then play around with 2 availability zones, 2 false domains and 2 update domains. I could as well increase it. But if it is 2 virtual machines and I have specified 3 false domains and 5 update domains there, it is not possible that both virtual machines will be in the same false domain and the same update domain, because I have 3 false domains to play around. So it randomly selects where it places it to without placing them. So there's an algorithm that would ensure that both of them are not in the same. It's just like you doing permutation and combination. There'll be an algorithm to say, okay, now I have 3 spaces to play around and I have just 2 virtual machines. Then the algorithm will say both of them would not be in the same location. And the same thing with update domain. And fault domain says virtual machine, the same fault domain share a common power source and physical network switch. So which means they'll be placed in different locations where you have different physical network switch and power source. Why this update domain is virtual machine, the same update domain will be restarted together during a maintenance. And if you now say you have 5 fault domains, then both of them can't be there. And this would always be by default because here would have specified that we want a managed disk. So if what I want is availability set, I'll do this. But mind you, availability set, yeah, what's it called, limited to a particular region, a particular zone rather. If what I want is a zone, I can play around with whatever zone I want. One is Lekki data center, one is main data rather, one is rack center, and one is MTN. I specify where I want them to be. Now, talking about the last option here, which is a skill set. Let's go back to the slide. Now, there are situations where you want to scale. And scaling means that increasing the amount of resource that you have available. And it can be vertical, it can be horizontal. Vertical scaling means that you are increasing the resources on still the same virtual machine. Maybe I started with a virtual machine that is 2 gig RAM and 2 vCPU, but I begin to observe that the performance is now becoming very slow. I'm consuming so much resources, it's spiking. So I can say, okay, now increase my CPU to say 8 vCPU and let's say 8 gig RAM. That is me scaling vertically. It's the same machine, I'm just upgrading it. And this guy has to be done manually. That means you have to specify another size for your virtual machine, and it would always involve that particular virtual machine restarting. Then you have horizontal scaling, where that scale out or private scaling. For this, you are increasing the number of instances that is serving a particular service. So that means I'm increasing the number of virtual machines that will be serving the same purpose. So if I started with 1 server, the workload on that particular server is becoming too much. So instead of me increasing the compute resource on the server, instead I had another server and make it 2 so that they share the load. And if that is also becoming overloaded, I also add another one. That is me scaling out horizontally. And when I see that, oh, the workload has now dropped, then I scale in. Now, it's easier for you to scale out and scale in because what you are doing is just adding and removing nodes than for you to scale up or probably scale down. Because if you are scaling up, number one, it involves you restarting that particular machine, adding more resources to it. And even when you are scaling down, you also restart that virtual machine and take it off. Let's assume it is physical. It means that you'll be unscrewing that particular server almost frequently. So both are possible within the cloud environment. If you are doing vertical scaling, all you need to do is change the size of your VMs. If you are scaling in or perhaps scale out, just look at one of the availability and redundancy options and see which one fits your purpose. You could do availability set, you could do availability zone, or you even make this automatic. That is where you now make use of auto scaling. Auto scaling can help you scale in or probably scale out. And if you are going to do auto scaling, you have to create what you refer to as a virtual machine skill set. So let me bring up the browser and see. So still using this VM as an instance. Okay. So if here, now coming to the last option that I have here, which is a skill set. For skill set, you have similar virtual machines that are created in an horizontal scaling model. And the creation of those virtual machines is not managed by you. It is not manual. It is managed by the skill set. All you need to do is define what will be the factors that will warrant increasing the number of VMs serving this particular purpose, and what will be the factor that will warrant reducing the number of VMs that will serve that particular purpose. So for me to use this, I have to create what I refer to as a skill set. And is either I do this at the point of creating the virtual machines, like here, if I do this, it will say, oh, you'll be redirected to where you create a skill set. Or even right from scratch, I can come here to say, if I search for skill set, so mind you, this search bar that you have here allows you to begin to search for different resources within Azure. So I can say I want to create a virtual machine skill set. So I either go and create that by default, or probably I do that from the VM when creating the VM. So if I come here, it says a virtual machine skill set lets you create and manage a group of load balance VMs. So those VMs are placed behind a load balancer so that there is no service interruption when you increase or probably reduce the number of nodes. Users don't observe. It doesn't impact them. It's not tied to any user experience, or probably, sorry, user impact. I'll put this there. So I'll call this let's assume web VM stats 01. And I'll put this in West Europe. I can specify what zone I want it to be. And here, what we said, the scaling can be automatic, but you'd also offer choices. Your orchestration mode decides how you want the scaling to be done. If you want it to be uniform, that means Azure would manage the creation of the VM for you, and all the VMs will be of the same type and the same config. That is uniform. If you want it to be flexible, in this particular case, you want to specify what type of virtual machine should be added or probably removed. Then it's going to be manual. So I go ahead and say, I want standard. I want the same, what's it called, image. Here you could talk about the security. If you want your virtual machine to use TPM. TPM is a module, an hardware module that is used for storing secret keys and stuff like that. So now, in the last class, we talked about this port instance. And this is also a very good instance where you can make use of ports. So I have a server farm. Let's assume it is this Black Friday, where you have this Conga for Yakata promo. And during that period, Conga would have observed that the number of traffic hitting their site used to be high. I could remember when they started, the first year they started, was it Jumia or Conga? Then they said they were going to open, they had a lot of hidden treasures within their e-commerce site, so that maybe you could buy an iPhone, then you could buy it for 10,000 naira. I can't remember, just give me an instance. But you just need to be able to search the e-commerce site to see that particular product itself. They made it some kind of hunt there, and it opened 12 in the morning. Just a few minutes after 12, Conga site was not reachable. Nobody could access it. And people were like, oh, it's a scam. These people, they just want to scam us and stuff like that. And some speculation was like, because the competition then between Conga and Jumia was very tough. And the idea was that, no, it was Jumia. Maybe they are doing DOS for them, denial of service and stuff like that. But it was none of them. Conga didn't expect and didn't manage that expectation well, and they actually DDoS themselves. You can DDoS yourself, that's doing a denial of service against yourself, if you have not optimized your service or probably your server to take the number of traffic that is eating it. So if I have spec my web servers to only take 100,000 requests within a period, but I'm seeing double that, your services will be so choked up that the server can either crash or probably shut down. And that was actually what happened. But the cloud offers you flexibility to even expect that when you're experiencing high traffic, what are those parameters, metrics that can show on your server? You could have high CPU spike. You could have a large number of internet, data processing requests on your NIC. You could also have your RAM sparking. If I'm able to manage this metric, then I'm able to create a skill set to say, oh, when the CPU on my virtual machine hits 70% or above, create another virtual machine and share the load. When it hits 80%, create another virtual machine and share the load. So as the traffic begins to get high, it creates more instances and begin to share the load so that just one node does not continue to do the work and die. And if the traffic drops to 70%, drop one virtual machine. It drops further, drop one virtual machine. And the number of minimum virtual machine I should have at any point in time is maybe 2. So you specify that within your skill rule when you create a skill set. And that was what Conga ought to have done. Then, but I understand they actually, what's it called? They've done better because they've done several other Conga for Yakata after that period without such experience. So, yeah.
Yeah, it's me then. While you're speaking about this, I was just thinking of the cost implication. So is Azure prepaid or postpaid? Because if my VMs are just increasing based on demand, and you know that you cannot really predict what the exact demand will be, especially giving your example of the Konga Yakata promo,
Yeah.
right? So how would I manage payments? Like if I have money in my accounts, might it not be exhausted, or would it be space for me such that if it is, I can be informed to increase it?
So as well as pay as you go.
Okay.
Yeah, you could also have a reserve commitment where you say you commit to using certain resources for so period that would attract discounts. You could get up to 30-40% discount depending on maybe if you are using spot instance, maybe if you are using a reserved instance. Reserved instance saying that, oh, this VM I'm committing to use it for 3 years. So instead of they charging you the use for 3 years, they could give you up to 40% discount for using it for 3 years that way and stuff like that. That's number one. Number two, the charges doesn't hit your card instantly. You get a billing. There's a billing cycle, so you get your bills at the end of every month. That's number two. Number three, you could as well create budget and set budget. You could do that at your subscription level. You could do that at your resource group level also. So I could say for this resource group, all the resources within it, my target budget is so amount. So when you hit that particular budget, you begin to get notification and specify what should happen if it's trying to exceed that particular budget as well. That helps you manage cost. But however, mind you, your costs are also, even though they are displayed here as per month. If I can check this, even though this is showing as per month, your actual billing is actually per hour. So which means if I use this for just 1 hour, it's just going to charge me for that particular hour. If I use it for less than an hour, it also prorates it and charge me for that particular period. So which means your that spike, especially when you are using it to manage expectation, that spike might not last for so long. And that is where the use of spot instance comes in. Because if what I'm using my skill set is to manage that type of spike, there's no point me using a full-fledged what's it called machine that I'll pay for, that I would commit to. I could use spots in this particular case. And for that spot, it is because your spots can be available. You have pool. Your spot is a pool that is available at random. So even if this one is not available, this one is available. If this one is not available, this one is not available. So I can use spot in that particular instance. And if the duration of let's say that I spike expectation, because maybe it's a peak period for me on my e-commerce site, it might last for maybe an hour, 2 hours, 3 hours, 4 hours, maybe 24 hours, 48 hours, 36 hours. So those extra nodes that are added, I'm only charged for that particular period of time. So those are some of the ways you could manage cost in that particular. But it would be something that you would naturally expect, or that you know of, to say, okay, now, oh, if this happens, yes, and that might be the justification for your spend at the end of the month. If there's a spike in this, okay, yeah, the spike is there because we add a large number of traffic, which naturally should translate to more sales for you too as well, because you have more people hitting your site.
Thanks, it's clear indeed.
Yeah. So this okay, I was creating a skill set. I said, yeah, we could use a spot here and pay less, and I could configure what should happen. I could say just stop my virtual machine. That is fine. And the size of my virtual machine, I'll leave that the way it was. It's my back button. So I would leave it at stop and deallocate. Yeah, this is going to be SSH. I'll go ahead and create. So this would create minimum of 2 virtual machines for me in a skill set. I can increase, so you can see here, initial instance count is going to create, what's the validation here? It says the result ID size to deploy to different, probably that spot is not available in that zone. Let me come back here. Oh, okay. I'll just allow it. I'll call this web 001. West Europe. I'll leave that. I'll leave this guy. I'll just allow you standard here. So I'll go create. So it's going to start with 2 VMs, and it's going to create the 2 VMs. They'll be identical VMs. So I don't need to, I'll just download this guy. I don't need to manage the creation of the additional VM. Yes. This guy, big one. So while this guy is creating, let me come here, like I have. Okay, so it has created 1 out of the 2 VMs. So I can say I have 1 instance up. Okay, both of them are done now. So if I refresh, so yeah, I have 2. So if I come here and I come to instances, that's the VMs, I can see 2 VMs created for me, and both of them are up. And the whole disk and management and all those stuffs, even the size. Okay, so while before we come back here, so if I need to change, if I need to scale up and down, now this scaling here, instances, this scaling here is actually scaling in and out, adding more instances, increasing it to 4, 5, 6, 7 when as demanded. And if I want to scale up and down, what I can do is change the size, resizing. I said it earlier that what you do is just change the size. And if you want to change the size of here, you just need to come to size here and specify what will be the new size. Currently, this guy is 1 vCPU 3.5 gig RAM. If I want to increase it, I'll have to come here and say resize. But when you resize, you have to restart that particular VM for it to take effect. So this number of VMs here. So if I come here to scaling, here I can specify what should trigger my scale in and probably my scale out. It can be manual. Here you can see auto scale is a built-in feature that helps application perform their best when demand changes, and you can choose to scale resource manually to a particular count, or you create a scale policy that is based on metrics, based on schedule. That based on metric or schedule. So I say custom auto scale here. You give your auto scale a name. Then here you specify your scale condition. Your scale condition can be that based on metric or probably to a particular instance. Here for a particular instance, it is fixed to say it should be 2 all the time. If it is based on metric, then I can specify what should be the minimum. I can specify what could be the maximum. So if I say the minimum is 1 and the maximum is, let's say, 5. So no matter the amount of workload I experience, the maximum the VMs can increase to is to 5, which is also another way I can manage my cost. Then I will now specify the rule that will be responsible for either increasing the number of VMs or perhaps decreasing the number of VMs. And I can do that here from the rules. I can come here to say add what's it called rule. So here I have my resource type. Your metrics will be something that you can always factor as will be a symptom when you begin to see that particular increase usage. It could be CPU, it could be other resources. Like here I have maybe disk input output, read write operation, VM cache, especially this VM cached IHOPS could speak to your RAM or probably even your disk, your bandwidth, network traffic, inflow and outflow, disk read write operation. Then you also have a percentage CPU. So I can say my average percentage CPU is 40.46%. Okay, the average. So presently, this is showing me the average. My average is actually 40.46%. But I'm saying that if this average CPU increases up to 70% for a period of 10 minutes, if it experiences that increase in CPU usage for a period of 10 minutes, what should happen? The action is that it should increase it by 1. Mind you, I said my minimum is 1, so which means I'll start with 1. Or if I put it back to 2, which is what I created in first instance. So I'll say increase this guy by 1. Increase, this is my count here. Increase it by 1. So this is my cooldown minutes. That is your cooldown minutes in this particular case, the amount of time you wait before this increase would take place. I'll specify that here. If I add this, I have to come here again to add another rule. This is my scale up rule. This guy here is my scale up rule. If I add another rule here, then I can come here to say, so currently my CPU usage, because your CPU will always go up and down. So here, I'll say if it is now below, or if it is less than 70% for 10 minutes, what should I do? Decrease my count by 1. So I'm using this guy's 10 minutes cooldown period, decrease my count by 1. Then I'll say add. So this rule would apply. My scale in rule and my scale out rule, then I can save this guy. So if at any point in time, I experience a CPU spike, this guy will increase by 2. sorry, increase by 1, that means it become 2, it's become 3 rather. If I go ahead again to this my scale out, I add condition here again to say when this guy this one is, if I'm using if I come to add room, I say 80%, because it's very possible that this guy, for a particular reason, it just continues to increase, then increase count by 1. So if this guy increases by 70, it will increase by 1. If it falls down from 70, maybe less than 70, it will decrease it by 1. If instead of reducing, it increases again to 80%, it will increase it by another 1. So which means at 80%, I will have 4 VMs running. I will have 4 VMs running. And when it eventually reduces, I would have a minimum of 2 VMs running. That is what a skill set does. Any question?
Yeah, I was just wondering. So the VMs that it will be increasing, it will automatically duplicated, yeah?
Yeah, exactly.
Okay.
It creates a
Same.
duplicate copy of the same
Okay.
VMs.
The
So
same VMs
now,
several times.
if the VMs are your, let's assume web application.
Yeah.
So I expect the question would have been, oh, so how will you have your web servers and stuff like that? And maybe your application, your e-commerce application. So in such situation, what you do is you create a custom image. I did mention that you could have individuals creating custom images that they put in the marketplace, but you as an individual could also create your custom image. So which means your custom image would have been injected with your web application and the configuration already done. You now use that as the operating system image for your scaling. So when each time it is creating a new VM, it is creating a VM that already contains your web application and the necessary configuration with the service connection points connecting to the database, maybe connecting to the load balancer as well. So the VM just comes up and begins to take requests and attend to requests. That's the way that works.
Roger. Oh my God, I lost my thought. But there's a question in the chat box from Sharifa. She's
Okay.
asking,
Let me
is
see.
SSH same as hash keys?
No. SSH is a remote connectivity protocol. It's actually a network protocol for connecting remotely to a service or probably to a host. While your hash key is just a value that you get when you run an hashing algorithm against a resource like a file. So, and that hashing algorithm is a unique identity for that particular file or resource at that point in time. And if that file or resource changes, the hash values would also change. So even if I create a document that has 2 line space in it, and I run an hashing algorithm against it, and it gives me a hash value of AB. If I reduce the 2 line space to 3 line space, they are not the same document. So my hash value would change. So your hash is just a unique identity for an cryptographic unique identity for a resource like a file. While SSH is a protocol, but the protocol makes use of public key and private key for establishing remote connection and authentication. I hope that answers your question.
Yeah, so Roger, the question I was trying to ask is to create the image from your configured application setup. Yeah. Can that be done within Azure? Or
No. So the
I
way
have to do it
images are,
outside and import it?
yeah, you have to do it outside. So the way images
Okay.
are done is you would have installed the set up your server off Azure, outside of Azure. You'd have set it up, install all your dependencies, let's assume it's a Windows server, because maybe you are hosting an ASP.NET application. You'd have installed Windows Server, installed IIS, configure IIS, put your web application there, configure the database connection strings, apply SSL, everything. Then you now capture the image. How do I describe it? So, which means you'd capture the current state of that particular server as an image. The image is a file. You have tools available. If you are doing it off premise, you have tools that you could use to do that. If you are doing it for Azure, so Microsoft also provided you tools that you could use to reference and capture your image. That image is now a file that you now upload to Azure, and it becomes available at that point where you need to create your virtual machines.
Thank you.
You could also edit an existing image within Azure, do extra configuration, and re-upload it.
Thanks, Ross.
So let's now move to storage. Azure storage service. Yes, it comes. So one of the type of storage that you use within Azure, which we have seen, is the disk. So just before we okay, maybe I'll cover that under the storage. So the type of storage that you use is the disk storage. But outside disk storage, there are several other types of storage service available in Azure. You have containers, which are used for storing objects or binary data, like files, image files, video files, music files, document logs, database data, backup files, and the likes. Those are binary data, and they are referred to as blob, and you store them in Azure containers. You have Azure tables, which are ideal for storing non-structured and structured and non-relational data. You can think of them like tables that are used for NoSQL kind of data, non-SQL related data. Then you have Azure queues. Queues are used for messaging. A queue is just a container where you drop a notification that another application or private server can pick up to act on. That is a queue. So they are used for communication between different applications. Then you also have Azure files, which are naturally shared folders. Then you have Azure managed disks, which are block storage that you use for virtual machines. These Azure files are similar to the share folder that you create when you right click on the folder and say share, and access it using the double backslash name of server / name of shared folder. These guys are block storage that looks like directly attached disks that you use for your operating system. Now, when you are creating storage in Azure, your starting point of creating a storage is creating a storage account. A storage account is a resource that storage services are tied to. So you have a storage account from which you now begin to define what type of storage service you have. Then you have these 4 types of storage account. Standard general purpose 2 that you can use for all the type of storage services, block, file, queue, table, including data storage. Then you now have special purpose storage account, which are used for premium type of storage service, like premium block blobs, premium file shares, premium page blobs. Why are they called premium? Because they are high performance storage service. You'd use them in storage critical or probably storage intensive scenarios where you require a very high IHOPS, input output operations, read write operations, So, and a large number of them are driven by SSD and ultra SSD disks, where the general purpose will most likely be driven by either standard SSD or standard HDD disks. And for security, all storage accounts are encrypted at rest by default using storage service encryption. Microsoft encrypts them by default, but you can, if you want to, also define what will be your own encryption key. You know, this encryption in cryptography, so which means you have an encryption key, that public private key, or probably just a key. And then you can also bring your own key that will be used for encryption. So before we look at redundancy, let's see what the storage account looks like. And let's create a first storage account. So if I come back here, if I come to storage accounts, so I'll come here to say create. So you can say an Azure storage is a managed service providing cloud storage that is highly available, secure, durable, scalable, and redundant. So for this also, you'd see how there are default redundancy options that offers you certain level of availability. And if you demand more level of availability, that's SLA, then you could do more things, pay more to get that level of redundancy. So here I would use my resource group here. I'll call this, let's say, week 4 account. Your storage account name has to be unique. So it can be standard. If it is standard, it is general purpose version 2 account. But we said there are premium cases where we want premium storage account for premium services like premium blob, premium file, or probably premium container. I would come here to say I want page blobs premium, block blobs premium, or probably file share blobs premium. But here I would go ahead to say I want a standard, and this premium would obviously cost more than others. Therefore, redundancy also, we'll come back here to speak about the various redundancy options that we have. But by default, there's a level of redundancy that you have. But here, the default level of redundancy you have is the locally, which is the smallest and the cheapest, is the local redundant storage. And what the local redundant storage does is create multiple copies of your files. So if I create a storage account here and I store a file in it, a duplicate copy of that storage is created for me, although not visible to me, for Microsoft's own use, so that should something go wrong, which is meant to be covered within their SLA, that storage, the other copy is presented for use. So I'll go ahead to say create. Say create again. Okay. So this guy is up. I'll go to resource. So this is my storage account. This is the first thing I need to create. And under the general purpose version 2 storage account, you could have the 4 types of storage. You could provision the 4 types of storage service. Meanwhile, under those premium ones, they are specific. They are premium specific. If I do blob, I can only do blob. If I do premium file, I can only do premium file. I can only do file shares. If I do premium blob page, I can only do page blob files. So yeah, container is for blobs. File shares is for shared folders using the standard Microsoft SMB protocol, but this time I'm being served through the web using REST API. You have queues also, and you have tables. Starting with container, for me to create a container, like we said, your containers are something like your blobs, because container is the storage service that stores your blob. The type of files you would have here include maybe your video, your picture, and likes of them. If I want to create a container, I could call this media. So a very good use case for this is when you are creating a website and you need a location to store your media assets, like your videos, which you can now reference and present within your website, your pictures, maybe attachment and stuff like that. You could have them here. So here I have my blob. I can upload content to it right from here. I can come here to select a file. Let's see if I have a picture here. Okay, let me see. Yeah, I would say these. So we'll come back to this tier. So let me just come back here and say upload. So I have my file here. It could be any type of file. So let me come back here again and create a file share. I'll call these, let me call these admin. I'll come here, I'll say create. This is now a shared folder. Even though I can add files to it from here as well. If I come here to say select file, press a download. Okay, I'll put this here. I'll say upload. Now, I can actually add data to both of them from the back end here, but they don't serve the same use case or public purpose. This admin file share is meant to be mounted or mapped as a network shared drive, either on a Windows PC or a Linux PC. On a Windows PC, it will use SMB protocol. On a network PC, it will use network file system protocol. Meanwhile, for container, the content of the container would always come with a unique URL with which they can be accessed. And it is that URL which you call service endpoint. It is that URL that will be referenced when you need to use them, primarily maybe to store your websites or probably even backup data and stuff like that. That is what you do. So if I come to this guy now, if I copy this and I come here and paste it here, so it says does not, why doesn't it exist? What's the let me come back here. Is this public? Must go back to my container. Okay, this guy is private, except I change to public. Okay, we'll still come back to change to public. Or queues also, you use queues naturally as both queues and tables as strings and queries that you use within your application to share information within two applications, while for tables to store structured data using no SQL format. That is the use case for these two. Like I said, when you do general purpose, what you are looking at is primarily what would be your factor for using general purpose would be number spent and also use case. And we have said in cases where you don't need to do storage intensive read-write access, then you could use general purpose, because the underlying type of disk that is servicing general purpose is HDD and standard HDD. But if you need something faster, then you can do premium. But nevertheless, for a number of them, both for file shares and containers, so let me just speak to that now. Both file shares and containers, you could also have tiers. Tier would determine how often do you need to read and write out of that storage. And that will be a factor of how much you pay and also how fast the type of disk Microsoft would store it. So let's, if I come to container, let me come to this media container, for instance. Presently, I can see the access tier is hot, which means that I am saying that this file, I'll be accessing it very frequently. So which means make it available on a standard disk that I'll be accessing frequently. That is number one. Then number two, I would also be incurring cost in terms of the traffic for accessing, reading, or probably writing after that particular disk. But I could as well change this guy. And what are the other tiers that we have? If I come here, let me change from here. If I come here, I have cool and I have archive. The major difference between cool and archive is that for cool, I'm still doing a read write. So just putting it into context. You can refer to auth as something that you access, read and write out of, say every day. Cool is something I read and write to maybe once in a week, maximum say maybe 4 times in a month. This is just trying to put figure, probably create context out of it. They are not specific. While archive are things that naturally I would not access for a long time. I'm just dumping it there because they are just an archive repository. So yeah, I'm saying that you could go and keep them on a very cheap disk that is not expensive. So I should pay less for it. So the colder the type of disk, the lesser you pay. But even though you are paying less in terms of the cost of the disks, you pay more in accessing them. So my cost for auth disks will be high, but the cost of accessing it will be low because naturally I'm expected to access it quite frequently. The cost of my cool disks will be lesser than that of the hot, and the cost of accessing it would also be more expensive than that of the hot. The cost of the disks on which I'll be paying for disks on the archive disks would be way cheaper than any of these two. But when I need to access it, I'll pay more. Why is it that way? So that you know that an archive is actually an archive and you're not meant to access it quite frequently. So if there's now a need for you to access it more than 3 or 4 times in a month, then it's no more an archive. So you'd have to pay because now they have stored it on a cheap disk. You now have to pay for that frequent access by paying for the access cost. That is tiering. And this tiering actually applies to your blob, which is your container. And the same thing also applies to your file shares. But for file shares, using different terminology. So if I come to this file share, admin file share that I've created, I can also come here to say change tier. But for the tier, you can see I have auth, I have cool, then I have transaction optimized. Auth, just like for the container, I'm saying this guy, I'll be accessing it quite frequently. Then the cost of the disk will be much higher than the cost of access. For cool, less frequently. Transaction optimized, I can't say, but try to match. That's what transaction optimized is. Try to match it with the rate at which you see that I write, or probably I read out of that particular shared folder. That is what transaction optimized is. And you can actually switch between either of them. For premium, you can't do premium here because premium is naturally meant to be hot disks. But because this storage account itself is not a premium storage account, so I can't switch to a premium here. For me to switch to a premium, then I have to go and create a premium storage account for the type of storage service that I so desire. Now that is access. Let's come to redundancy and availability. You have these types of how do I put it, categories. When specifying your storage account, you're allowed to specify your redundancy category. And the redundancy category that you specify will determine what level of redundancy or probably availability is going to be tied to your storage account. Number one that you have is locally redundant storage. And what locally redundant storage does is to create 3 copies of your data or 3 copies of your storage account within a single data center. So which means if my data center is in the, let's say, main data that is in Lekki and my storage account is there, 3 copies of my data will be maintained so that if anything goes, they will be maintained on different storage units within the same data center, so that if something goes wrong with one and it goes up, maybe the storage is no more accessible, I am switched to the other one. So I have that 3 copies at every point in time. So which means I am redundant to failures that could affect that particular data center or probably infrastructure, maybe power, cooling, or probably network connectivity. And this gives me up to 99.99999. That's about 11 nines availability. 99.9999999 availability. And it is the lowest level of availability that you can have. Then you now have the zone redundant storage. This would replicate. So let me clear this off and just use this is main data, this is rack center. They are all in the Lagos region, LA region. So my locally redundant LRS, let's assume that the zone at where my storage account is stored is here in the main data. It would create 3 copies. It will create 3 copies of my files, one here on this data center or probably infrastructure, another one here and that. So if one goes off, it is available. Then if I go for zone redundant, what zone redundant does is to synchronously replicate. Synchronization means that as I am writing the data here, which is my primary storage account location, a copy is synchronized or probably is replicated to another zone. So if anything goes wrong with this zone, my data is still available in this zone. So, and each storage cluster is separated naturally. This guy is physically separate from this guy. That is storage, the zone redundant storage. Then you now have the geo-redundant storage. For geo-redundant storage, you are saying maintain copies of my data in more than one region, and you would specify the region yourself. So I can say the Lagos region and the South Africa region. So after 3 copies have been maintained, because LSR is the default here, after 3 copies have been maintained here, a storage account is created for me in the South Africa region. And in that South Africa region, another 3 copy is maintained for me there. So you have 6 replicas in 2 regions. And it will protect you against regional disaster. If anything goes wrong with Lagos, you don't pray to see it, then your data will still be available within the South Africa region. Copy is asynchronous. The difference between synchronous and synchronous is that for synchronous copy, it means that the read-write operation will not be termed as complete until the second copy is also complete. While asynchronous, it means that the synchronization will start after the writing is complete here. then the job would go underground to now do application here. So which means at any point in time, there may be a gap in the version of data that you have in the primary region and the secondary region. For synchronous, there will be no gap because the read-write operation would not stop until that of the secondary copy is created. So if that of the secondary copy fails, the read-write operation will tell you that it failed and it won't even be available in the primary copy. So which means you would know and you have to rewrite. But for the asynchronous, you wouldn't know because it is going in the background. It will only tell you write complete because it is done right into the primary location, while the secondary location writing will be asynchronous. Then you'd also have the read access geo-redundant. For this geo-redundant, both copies in Lagos and South Africa are read-writable. You can read to them, you can write to them. For the read access geo-redundant, what you are maintaining is a read-only copy in the secondary data center. And you have a secondary endpoint, and this has to be tied with your recovery point objective, because what it means is that if this primary data center goes down, or this primary region rather, you can only read the content of the secondary, you can't write to it. For this DRS, you can read, you can write. But actually, both of them, or in all cases, it means that you are paying more. You are paying more than what you would naturally pay if you are doing LRS alone. You pay more for ZRS, you pay more for GRS and read access GRS. Now, each of these storage are referred to as endpoints, which are URLs. Like I said earlier, your storage within the Azure storage service, especially your container tables queues, are accessed through the web using REST API. The REST API is served either through HTTP or probably HTTP protocol, even including your shared folder, SMB. They are served using through a REST API using HTTP or probably HTTP protocol. So they all have URLs, which you actually refer to as the endpoints with which you connect to them. And their URLs would always they look similar, but it will only give you an idea of what service you are accessing. So if I come back here, this is my file share. If I copy this URL, let me do Notepad. See if I can do Notepad. Yeah. So I'll copy this URL and paste it on Notepad. So are we able to see this text? Hello?
Yes,
Yes, yes.
Okay. Let me just try to increase it again. So you can see this guy. This is the connection endpoint part, where I have the name of my storage account, the name of the storage service, and this guy is a custom. This is the complete URL. It is saying that I have the file service, the storage account of the file service that is on the core.windows.net domain, while this particular part gives me the name of my share and the name of the file. This is the name of my shared folder, and this is the name of the file. That is for the file share. If I come back to container, come to media, copy this guy. So you can see this one is blob. Name of my storage account, the name of the file tab, and this. This is saying that I have a container named media on which I have this file. This is saying that I have a share folder named admin, which has this. And the same thing would also go for queues and tables. They will all have their own. So like for this one is directly here. So I say I have the queue. This guy is a queue on this storage account, and the name of the queue is this. So the service type would always be specified in the URL, and you know when you see the URL. However, you can actually customize those URL, because if you are so the way these storage accounts works is that it's very easy for you to create application with them, reference them within the application, unlike normal legacy storage system that you are not able to reference as a part within your programs. But this URL, because they are served as REST API and they align with the HTTP and HTTPS protocol, then you're able to reference them within an application that you create. So, however, if you need them to be accessed directly without being used, for instance, you have instances where you could use your container directly. A large number of times you are using your file shares directly. For queues and tables, you don't use them directly. You actually use them as for storing data within your application. So in cases where you need to use them directly and you don't want to use this standard Microsoft name, you could always create a CNAME record for them. You remember CNAME record. So CNAME record is an alias. If my domain is contoso.com and the name of the storage account I've created is this contoso blobs.core.windows.net, then I can map blobs.contoso.com to this, so that what I am accessing through my URL is blobs.contoso.com, not this Microsoft own longer URL. And I'd wanted to do something earlier. Let me come back to it. That container that we created, that file, we wanted to access it directly earlier, but we got an error. So let me come back to that. Now, you have access level probably within your container, where you're able to specify if you want your container to be anonymous, if you want it to be public, or probably want it to be private. Like this guy is private now. So I'm not able, except I specify my access strings or probably keys, I'm not able to access it. If I make it anonymous or probably public, nobody needs the access key to access the content of this particular file. So if I go to media, yeah, that's come, no, just let me do this at the level of the container. Is now blob service, says public. Okay, I already enabled this public access here. So I'll come back here. Yeah, let me do so if I come here and get this guy URL. So what it does is you can see it's not downloading the file. It's not like maybe it's downloading the file for me. Instead, it is serving the file for me as a web content that I'm meant to view. So naturally, what this means is that in actual fact, I could even create a static website out of blob. And what that means is that I can create an HTML page and serve it into my blob and just customize the URL, and people will see it as my website. Meanwhile, it is just a single file, because when natural, that's why I call it a static website. Just a single HTML file, which means I don't naturally need to go and set up IIS and all those stuff if it is a static web page. If it's a single page website, I can serve a single web page website using my container. And if I come here to say static website, and I say disable, enable static website on blob service allow you to host static content, and web pages may include static content, including client-side scripts, because it is serving this to me, it is rendering it to me like a web content, which means my browser can interpret whatever it needs to interpret to present this to me as a web content, rather than once I click on the URL, it downloads it as a file. It's not seeing it as a file that is meant to be downloaded. So that's, if I enable this, I can specify what will be my index page. And let me see if we can give this a try. We'll just create one. If I copy sample HTML web page. Let's quickly create. I don't need. I need a full. Ask me to register. Okay. Let's just quickly see how this works. So I have John Doe, yes, public HTML, making sense. Yep. Yep. So I'll copy. Is this guy extracted already? Okay. So I'll come here to this guy. My index page here is
Raji, we can't see your screen, please.
oops.
Oh, I can see it.
Let me see. Oh, sorry. How about now? Are you seeing it now?
It's coming
Yes,
up.
it's
It's
up.
loading.
Oh, okay. Sorry.
Yes,
Just
we
let me
can
know
see.
once it's up. Okay.
Stop.
So my index page here is index.html. The extension for this file is should be HTML properties. Yeah. This index.html. So I'll come here to say index.html. I'll say save. I'll come to my container. Here is my container. So I have this web here. I'll come here, I would open this, and here I would upload all the whole of those contents in that folder. Where's John Doe, public. I'll upload this, and this. This. Then I'll upload. Did you upload that folder? I doubt. Let me check. Okay, first, let me go and see this guy first. Web magazine. See what this guy presents to us. It says this guy not found. Wow. Invalid. Okay. Um, that folder was not updated. The folder contained. So naturally, this is actually displaying as a web page, but without the formatting. The formatting is in. Let me get the formatting across to that folder. In that this asset. So come back here. This guy should allow me to don't want to do the whole of this stuff manually. Because of the several layout files I have, I would have to. Okay, I would only fix the issue of the CSS, then would continue open with Notepad. So the CSS is meant to be in a subfolder and bootstrap. Control F. CSS. Okay. So this guy is now going to be in. It's not going to be directly here. Control S. What other assets do I have here? I have images. I have images. Control F. ING. Where is it? Where are the images? Where are the images? Where are the images? Okay. Let me search with one of them here, which is web-2, web-2, web-2. Anybody seen? Okay, yeah, I've seen it. Don't worry. So here I have this guy. I'll just search for this and I would remove it this way. I only do for a few of them to save time. So that's enough. So I'll just replace that index file here. I'll upload and ask it to overwrite. Index open, overwrite this guy and upload. Then reload this guy. Okay. So now this is my website. Without me setting up a Windows server and the likes, I'm serving my website. So all I need to do to now make this available is just go and create a CNAME record for this guy. So presently it's accessible as my web account, my blog, code of Windows, the web folder. This guy has a slash in it, so you won't be able to access this web for this dollar sign. You won't be able to access it directly. And my index page. Then I'm happy to, let's say, maybe a tunde.adewale.com, and it's going to serve this page. So you can actually use your blob storage to host a static website, which means a website that is not writing to a database. It's just static. The content in it would remain, but your styling, your JavaScript, and all those stuffs will still be presentable. So that is that for blob. Now moving on. So we've seen the other purposes of blob would be serving images, storing files or digital access, streaming your video, audio, storing data for analysis, and the likes. And we've spoken about the blob access tier. Optimized for frequent access. Cool, optimized for storing large amounts of data that is infrequently accessed, stored for at least 30 days. Then you have archive, that is, that will remain and you won't access for the next 180 days, which is about 6 months. Now, another concept within storage is how you access them programmatically within your program. Like I said, a lot of this storage, you'd have to use them within your applications, apart from some of them that you can access directly. So there will be the idea of how do I access them? How do I authenticate? Because for you to be able to access and read and write out of those storage, you need to authenticate. For users to view, they don't need to authenticate. Like me viewing that site, I don't need to authenticate against that storage because I've made that folder public, so it is accessible. But for me to be able to change the content and write to it, I need to authenticate. So if I'm doing it directly from a storage account, I could upload just like I've just uploaded, upload, download, overwrite, and change stuff like that. But if I'm doing it from an application, or maybe I need someone to do some work for me, and I need to grant them access to that particular storage, how do I manage that without giving them access to the whole of my environment? And that is where you have keys, you have storage keys, and you have shared access storage. Starting with storage keys, let me bring up my my browser. Starting with storage keys, if I come back here, where is it? If I come back to my blog, I come back to this storage account. Here I would have access keys. All storage accounts will come with 2 access keys that can be changed. You can rotate them. Your access key authenticates your application's request to this storage account. When you are using the storage account within your application will need this key to authenticate itself. And you can use either of them. So why do we have to? Now, it is recommended that you always rotate. That means you always change these keys. But when you change the key, it means that the application on which you are using it would currently disconnect. You have to go and update it. So you have to, which is also a form of redundancy. You have to such that my application can continue to use key 2 while I change key 1. There will be no break in what's it called, that particular application. That is why you have 2 keys. You can use either of them, but the essence of it is that so that when you are changing one, the other one still continues to work. Another way you could now, if you use access key, access key will grant the application or the holder to the whole of the storage account. And mind you, under the storage account, you have 4 different services. I have blobs, containers, I have file shares, queues, I have tables. You have situations where the business of the application is with blobs alone. It has no business with file shares or queues. Or maybe the business is with queues. It has no business with these other ones. But if you go and use your key, and if a third party gains access to that particular key, then they're able to access the whole of your storage account and all its content. Then you now have, that is where you now have a shared access storage signature, where you're able to streamline specifically what service would you want to be accessed, and even put a timestamp to it. I can say this key will be usable for so period, and after this period, it expires. That means the holder, either application or probably human, would cease to gain access to that particular service after this expires. So for this, you're able to specify, for instance, if I want to grant access to just blob, I can check blob alone. And this guy, my allowed access type is the container. I want them to access this particular folder, not just the service, which is the account, or the object, which is the content. Then what is the level of the permission that I want? I could also streamline this. Maybe I want read write alone. I don't want them to be able to delete. Then blob versioning, you want to enable versioning, permission indexing, you want to do that as well. Then yeah, I can specify for how long will this be. Then you could even go ahead to restrict what IP address is allowed. And this works if you are designing the application on a server that you know the IP address, so that any other application, this is just security, security of least privilege, and you ensuring that you do some kind of level of zero trust. Only the application that I want is able to access this particular storage service or private storage account. Then you can specifically put the IP address of the server through which that request will be coming. For security purposes, also, the only web protocol you want to allow is HTTPS. Then, despite the fact that you are not giving out your access key directly, this storage account's access signature has to be signed by either of the storage key you have. So you have to specify which of them you want. Then you click on generate. Now, this now generates a connection string, which is combination of your storage account, storage access signature rather, and the blob service. That's this the URL for the type of service you're accessing. So like this guy now this is my web account, this is blob, and this is my signature. And within that signature, you can see the date that is allowed, where this guy would expire. So all you need to do is to use this string within your application, and you gain the application gains access. Now, your shared access signature can be defined at 2 levels. You can define it at the storage account level, which is at this level, and I can grant access to the storage account itself, or probably maybe to the container or to the object. And you could also define this guy at the object level. So if I come to containers and I come to, let's say, blob, or this media rather, let me come to this media. I can come to storage access tokens. So if I create my storage access token here, it is only this folder, or well, it's not a folder because your blob is not structured. It has no structure layer. This is just an object on its own. So it is only this object, this media object, that I am granting access to. If I generate a SAS here, it is only this media I'm granting access to. But if I do it here, this is my storage account. If I do it at this particular level, I can specify if I'm doing at this storage account level, at the container level, or probably at the object level as well. Then additionally, we talked about your tiers. You could actually have some kind of life cycle management, where there are possible scenarios where your files can always move from being an hot file to a core file and to an archive file. Hot file if it is a file that you currently use presently. So which means you need to access it quite frequently. Then over time, the rate of access reduces to maybe once in a month. Then you want to move it to a cool file so that it doesn't begin to occupy space within the hot space and you are paying more for it. You want to move it to a cool tier storage. Then over time, you are not accessing it that frequency again. You want to archive it. Then you move it to the archive. Then from the archive, eventually you note that it is a file that you don't need at all again. Then you now, what's it called? Delete it. So all you need to do is to create a lifecycle management rule here. So this rule is a rule-based and it works for general purpose version 2 files and also blob storage accounts. You have to note that this is the two file system it works with. And you use this policy to transition your data to different access tiers until the data is expired. So if I say add rule, I can give this rule a name. Let's say media for my media file. Then apply this rule to all blobs in my storage, or probably limit it to blob filters. You have to specify the filter. For instance, I want to limit it to that media folder. Then my blob type, I specify this. That you will talk about snapshot and versioning much later. So here I create my rule. If the blobs were last accessed, say 30 days ago, then move to cool storage. Then I go next. I specify what subfolder I want. Then I'll click on add. Then I can go back again to say I'll call this media 2. The same thing applies. I want it filtered. I'll go next. But in this case, I would say if it is last access 180 days, then move to archive. Then I'll go again, media. Then I'll say add. So naturally, what this means is that if there is a file within the media folder that the last modified date is about 30 days ago, it will move it to the cool archive. Then if this rule runs again, and within the cool archive it notes, it checks again, the last time that this file has been accessed is 180 days ago, then it moves it to the archive. Then I can now go ahead to say, create another rule that would eventually delete it. Then here I would say over 360 days, then delete. I can say delete that object. So I don't need to begin to manually do the content of my blob, the management of content of my blob, manually deleting them or probably saving them, backing them up and stuff like that. So you have that in place. Then you also have if you enable versioning or probably snapshot. Let me come back here. So snapshot is just a way to back up your files as such. Let me come yeah, where's that guy? Versioning. So currently I have versioning disabled. So what versioning does is as your file changes, it doesn't delete them, it doesn't delete the old version, instead it keeps other version, just the way OneDrive works, if you are familiar with OneDrive, such that you could have several versions of a file. You could have that, so you could track version, and you could as well enable soft delete, enable versioning for blobs, use versioning to automatically maintain previous versions or probably previous copies of your blob. That's versioning. Let me save this guy, save. Then you could also do snapshots. If I come to file shares here, so snapshots are more or less like backups, backup copies of what you have within your storage account at a particular point in time. If I presently I don't have snapshots, so I'll come here to say add snapshot. I can give it today's date as Saturday. If I say okay, what this does is it will look at the content of my shared folder or probably my container and captures it, more or less like create a freeze copy of it, such that I'm able to refer back to it at any point in time. If something goes wrong, you can see within this snapshot, this is the timestamp of the snapshot, this file is there. So if for any reason I mistakenly delete this file, if I delete this file, if I say delete, yes. Oh, then I just figured, oh, I've deleted this guy. Then I can come to snapshots. I still have it here, and I can view it from here and do whatever I need to do with this particular file. Like I can download, or probably I can restore it. I can say restore, overwrite the original, but there's no original there. Then one more thing I could do is enable backup. But the catch here is that what backup does is to automate the process of creating snapshot for you, so that you can specify frequency of creating snapshots. If you create this, it's going to use the Azure backup service to automate the process of creating this snapshot. So either use backup to create the snapshot, or probably create the snapshot manually. That is the idea behind this. So moving on, we've seen this URL that especially when you create your shared access signature, it specifies your token, the date that you specify for expiry, and other information. And so let me now come to these file shares. I said file shares are just like your shared folder. So naturally, you are not meant to access your shared folder using the browser. So they are meant to be mounted. So how do you mount your shared folder? This is a shared folder. If I come here and I say connect, I don't know, a number of us will be familiar with shared drive, how you map shared drive to your system. That's exactly the way you do this. So I'll come. If this guy is integrated with Active Directory, that means that I can authenticate using my Active Directory username and password. But if not, it would automatically map a shared access storage key to it. If I now run this command, let's run this guy. But before we run it, let's see what drives do I have on my system. This guy is blocking here. Okay, I will answer this later. So these are directly attached storage on my PC. So I want to map that storage to my system. When I map it to my system, now I should be able to see it as a mapped folder. So if I come here, all I need to do, what drive data I want to use drive Z as my drive letter. Then I would run this guy. So it first of all checks, SMB uses port 444. It checks if my network allows port 444, which is SMB. If it allows, then it maps it. So I would see this guy. So this is my file share. And I can open this guy. I can create files and folders. If I call this, what can I call it? Let's say movies. Just you can see the response is a little bit slow because of the type of storage it is. But if I create a premium file storage, it's going to be pretty fast, and you'd hardly be able to differentiate that it is not a directly attached storage on your system. Test documents. So in an environment where they have shared folders, or probably they have file servers being served by Microsoft file server resource manager, like a Windows server, and you have shared folders for different departments, and they know to move to the cloud, they can actually move that to the cloud using this technology, because it's still the same way that users will access it. They will access it as a mapped folder on their system. If I go back to check from the back end now, I could see that new folder that I created and the content of that folder as well. So you can see the movies folder, and you can see the file, test document. So that's how you access file share. You could also access it on a Linux machine as well as a Mac OS. Wow, this is already 1 o'clock. So let's see how much more do we have. So this is just showing difference between your blob and your Azure file. The Azure file share uses SMB, which is the legacy protocol for shared folders, but this time around it serves it using REST API across the web. While your Azure blob also uses REST API, that is why both of them are accessible using web protocol. For blobs, you do streaming files, images, videos, and the likes, while for Azure 5, primarily use it to lift and shift application to the cloud, or probably your normal methodology of accessing share folder within the environment and you want to move it to the cloud, you could use Azure file shares. So that is that so far. Questions? Any question?
Roger, I don't have any question.
No.
Okay.
Sorry, sir. I just want to
Yeah.
ask, regarding this file share that you just talked about, in a situation whereby you have like a SharePoint in your organization, can it be done via SharePoint too and be mapped to a workstation?
So it is possible for you to expose a shared folder to SharePoint so that SharePoint indexes it, and when you search, you see it from SharePoint. But even when you need to access it, it still takes the file directly from that shared folder. It's possible, and it is also possible to use Blob for that particular purpose. Yes, it's possible.
Okay, thank you, sir.
So please, after 8 weeks training, can we still be having class like a month? I can't say I can't commit to that at this moment, but hopefully. How can we
So
get
what did you say?
Windows?
What did you say?
So the question says that after the 8 weeks session, can we still be having class like at least a month?
Okay.
Yeah, so it's not what I can commit to at this moment, but it might be possible. Then how can we get Windows PowerShell application on our system? All your Windows 10 and Windows 11 has PowerShell, even starting from Windows 7 upwards, you have PowerShell by default. Just search for PowerShell. You see it comes pre-installed. Then on Windows 10, Windows 11 is it's pre-installed. If you don't have it, just okay. Yeah, you could as well, install the PowerShell as well. So activities for the week would revolve around creating virtual machines under different contexts and scenarios, as well as storage. Would create blob storage, would create Azure file shares, would also manage storage and the access token. So details for the activities I would send to us through the Discord channel. So if we have any other question, we took just too much time today. So if there are no questions, to have a great week ahead.
Thank you very much, Mr. Raj.
Yeah, thanks, guys.
Thank you.
Thank you, sir.
Thank you.
Thank you.
You're welcome.
Yeah.